Another 5 minutes we'll start, sir. About 45 or so. 32 attendees are there. Another 5 minutes we'll start with the session. A very warm evening to one and all present here, this virtual gathering. I welcome you all for the ATAL online FTP on revolutionizing electric vehicle powertrains, the role of Wide-Bandgap. wide-bandgap semiconductors in overcoming challenges and shaping the future trends. Today, we have Dr. Saravanan, Assistant Professor, Department of EEE of Amrita School of Engineering, as a chief guest to deliver the session on electric vehicles and charging system. Dr. Saravanan received his BE Electrical and Electronics Engineering in the year of 2012 from Karpagam College of Engineering, Coimbatore. And he did his master's in Power Electronics and Drives at Sri Krishna College of Engineering Technology, Coimbatore in the year 2014. And he also received his PhD degree at VIT University, Vellore in the year of 2017. His present work experience is as assistant professor in Amrita University, Coimbatore. He was awarded as prestigious travel grant by Asian Development Bank. At present, he is executing a project funded by DRDO, Government of India, focusing on more electric aircraft application. He is the author of about 47 papers published in reputed journals, including IEEE, Elsevier, Springer, and IET. His area of interest include high step-up DC to DC converter, PV array reconfiguration, electric vehicles, and battery management system. Now, I request Dr. Saravanan to go ahead with this session. Sir, please.
Yes, sir. It's a warm welcome. So I very much thank you to all. So let me share the presentation with you. I hope is my presentation is visible to you.
Yes, sir. It is visible, sir.
Yes, thank you, sir. Okay, good evening to all. So today is my topic. I'm going to present it on electric vehicle charging system. As we know that this ATAL FDP title itself is a wider band gap for the EV, which is challenging nowadays. So actually the drastic evolution happening on the EV vehicle. So the peoples are always want to be very faster in all aspects. So they don't want to wait for even charging the system. Even our mobile phone itself, we required very fast charging. Then only we can able to accessible. So that much of requirement is needed. So this type of title, it's most welcome for the researchers to do more lot of work on this area to achieve the faster and sophisticated systems for the EV implementation. So from that, I'm going to continue this charging system. So first, I will just explain that we all know that. So it's a general how the electric vehicles are evolved from the olden days to until now. Then from that, how what are the requirement? It's required to make use of the electric vehicle. That means before entering into electric vehicle, first step what we have to do, that and all we have to see in the way of flow. Then we had different types of charging system. As it is electric vehicle charging without any fuel source, the EV can't able to drive for a longer distance. So we need a different types. So in that case, how far this are all is going to be supported for our charging of this EV. Then to this, we're going to see the research areas where we can able to focus in future or currently how we can able to develop a different techniques which you have to reach the charging station with a more sophisticated and effective one with a faster manner. So these are all we're going to see it. So these are all my outline which I planned today. So as if you take a look of an introduction part, we know that the China plays the major role of generating a EV vehicle. So compared to other countries, other where the China has placed the very huge production of the EV vehicles in different aspects, especially they are making in all the heavy duties as well as lighter vehicles, all those things. US is the next of the 1.2 million level of only they are using for that. But as an Indian, we are very struggling. Still, we have to look into the electric vehicle concept, and we have to make more policies. Okay, we have to make regulatory bodies for making the EVs. Actually, it is all there, but we need to follow very stringent, and you have to in all the aspect how that EV infrastructure have to be established. Those things we have to look into it. So if you take a look of this evolution happens, it is not a new. Okay, it's already have been done it in 1899 itself. That first electric vehicle have been developed on that time. That time itself, it can able to reach 100 km/h. So that much of speed itself can be achieved. But due to the technology lacking, the battery and other sources, it is not getting into an that much plays in the transportation field. So that ICE engine as it is overcome for that case. So that's why EVs are now it's get up and it is start running in the race between the ICE engines. So actually the ICE engines can't able to use it in the all the environment, right? So obviously we need a electric vehicle which more suitable. So I hope the rovers like that and all in space vehicles. Mostly we have to focus on this EV vehicles. So that case, how far that EV vehicles can be utilized in the other space conditions. So that conditions and all we have to look into it, and we have to develop a appropriate EV vehicle with charging facility itself. Because as it is, if you take a look of this lunar vehicle and all, it can able to get the supply from the solar. With that, it is having some pull up conditions to make travel from all the areas in the space regions. So like that we so now so due to this evolving happening, so all the companies, which are all reputed companies, have been focused on the different variety of EV vehicles. They are ready to launch in different aspect with all the sophisticated systems. Nowadays, I hope everyone knows that it can able to extend and it can able to shrink. They're like that the vehicles are made nowadays. So as per the family, we can able to elaborate it, and also the powerful motors with the battery with the longer distance travel purpose and all. They are came into picture. Along with that, they are introducing the more and more intelligent aspects which are all included in this upcoming electrical vehicles. So soon, very soon, everyone will have to look into this kind of conditions. But the EV vehicle should have to be accompanied by every users. That is the main thing to make it enter into the EV sectors. And if you take a look of the sales, if in the India point of view, almost if you we can able to see most of the two wheelers which are all there nowadays. They are people are trying to use the two wheeler as a EV scooters and all. Next steps are this public transport like autos like that and all. People are moving into due to the very cost of the fuels. So the people are trying to make it use of the EV autos and all. Then rickshaws also came in that picture also. Then comes in the four wheelers. It's a e-car nowadays. Slowly, every families some level it is getting reached now. So from this table also we may know that the one of the famous companies, the Tesla, is only can reach very high speed and long distances and all. But recent days the Mahindra is came into picture in our country to reach this EV vehicle with more rugged and stability based vehicles and all. It's getting into market. Coming to the forecasting of this market, as I said, very soon the conventional vehicle like internal combustion engine is going to be reach a nullified condition. Then remaining things, something like hybrid systems and plug-in electric vehicle, those things and all, it's getting into conditions. But very soon the hybrid is the next stage to comes to zero position. because the no internal combustion is going to be used in the future. So now even though we are having a hybrid system like CNG with IC engines are using, like the same we are now focusing on the battery with IC engines, but that and all very soon it is going to be come to a very low conditions because the fuel outage is there. So that is the reason. Next, if we take a look of plug-in electric vehicle, otherwise it's a we are getting a charger. The plug-in hybrid is nothing but to charge that battery. We are using that. Other than that, now the people are fully focusing on the battery vehicle. So anyhow, in future is only with the EV battery vehicles only. So this is the future prediction based on this upcoming condition on the transportation field. I hope everyone knows this. If we are going with electric vehicle, what are the advantages we are having? So that the fuel is totally is going to be reduced on the case. Then obviously the maintenance is less, but I'm not talking about the battery maintenance. Battery you have to look into it in this category. And as it is an initiate level, the taxes is getting reduced for the consuming of EVs in our regular life. And as it is a healthy environment, I don't think so. So that because the batteries which are all manufacturing those things, it's a very all are in the chemical based only this day. So it should be so green and environmental friendly based battery have to be look into it. So if we are all focus on that, we'll make this EV into a green EVs. Okay. Okay, so these are all the introduction I like to share with you. Next, before entering into EV, but the people is very hesitate to consume, that means to buy a vehicle. The main reason is the anxiety of the EV system. What is that anxiety I'm talking about in the sense? Still, many of the people is not ready to buy a EV due to its charging needed, because as it is a IC, everyone knows as it is the IC engine, we can able to fill the fuel within a 2 minutes, 2 to 3 minutes. But how that EV is going to be charged? Because as we all seeing that the vehicle can able to reach the range of 220 kilometers, all those things, but if suppose the charge is very less, in the sense how we can able to do the charging station. So that is one of the biggest impact in front of us. So before we are shifting into a EV sector, first the based on that base level of establishment should be there, then only we can able to push our case into the EV sector. If else, it will very difficult. The people really afraid of getting a EV, and they don't know. For example, if they are traveling for a longer distance, suppose after that kilometer reached out, if there is no charging station in the sense, it is very difficult. But as we all can see that everywhere the fuel stations are available, so that is the like the same as our petrol, diesel, gasoline kind of fuel station should be there as like a EV stations. Until that, it will be something like some afraid of going into the EV sector. But nowadays, due to some of the evaluation happening on the Tata, Mahindra, MG, those kind of vehicles are getting into one market. So there are the chances we can able to see some of the places like malls, those things are all malls, and some outer side, some motels and all having the charging stations. In Kerala and all, they are putting the charging station in the petrol pump itself. So now only the slowly that EV is came into the stations condition. So for that, the infrastructure of EV charging station is one of the most requirement while we have to look into a EV sector. And if you take a look of here, if everyone are turned into EV, that is also a very difficult task by the supply production side. So it is very difficult because, as you know, that it is purely depend on the electricity in the sense. So that case, if sudden of increasing of EV sector, it makes the grid the become an instability condition. So that is another big most condition. So this stage that grid should be get support from other aspects also. That is one of the key points that we have to look into. Other points I'm talking about, we need to focus on more and more renewable energy sources have to be support for the grid. Then only our resources that we can able to generate the supply from the grid with a more effective manner. It will support all the cases of the electric sector. So in this case, the supporting of the grid should be there. Otherwise, EV charging also it's very difficult due to its high demand. The grid can't able to support on that case. So that much of production that side have to be increased by the government and also the power sector units also, because still we are depending on the thermal power plant, all those things. In the sense, it is very difficult to reach this condition, because as this case the coal also is going to be degraded and going to be completed out very soon. After that, the supply, energy supply, it's purely depend on some hydropower plant and other renewable energy sources only have to be make use of this. So which makes to satisfy the demand condition. Now, what happened if grid is interfaced with our EV charging system in the sense? So we have a two impact also is there. One is a positive side as well as negative side we can able to observe from this. As I already said, in the negative point of view, if you connect more load to the grid condition, it causes the stability, it's will getting poor, and there is a chance of more load demand is will happen. So obviously it will make the power outage condition. So that have to be look a very keen manner. So then only we can able to focus on the grid stability, because grid is, if it is affected, our all other industries and other requirements also will get affected due to this condition. So whenever the EV is getting evolved, based on that, that much of supply have to be generated for that to satisfy the EV charging condition. So that is one of the biggest important thing with this there. As well as the positive impact, if you take a look in the sense, we can have to have the regulation in that voltage. And also, I hope everyone know, as it is a battery source in the EV, suppose whenever the grid is getting affected or needs some more supply in the sense, there is a reversal of supply flow can be done with the help of this, because all the time all the vehicle is not going to be in the running condition. Sometimes some of the cases the office people will park their vehicle in the parking area of the office, so that vehicle and all you can able to check it and then they can use it for their supply. If any without of shortage of supply is there in the sense, that charges can be placed. So like that we had some positive impact also is there. But before entering into EV sector, that infrastructure maintaining that, want to establish the charging station with almost all the factor, and then that much of supply also we have to produce in this case. So that on this point we have to notice that the renewable energy source should get more and more have to be utilized for making the charging the condition. Okay, next comes charging system. Okay, as we are all having the EV vehicle, we have normally it is classified into three different types we can able to charge our systems, EV systems. One is by the regular conductive charging method. It's a normal plug point like a refilling is going to make it. With that, we have different categories are there due to its supply point of view and due to its connectivity and all the aspects it comes into the case. The conductive charging is more about the plug-in condition, so that we going to look into it. And next step is next we have another type is the battery swapping system. It is kind of an interesting one, but more and more research we have to do in this case, because we have a lot of struggle on the battery swapping itself. Next stage is a wireless charging, because all the time we can't able to depend on the wiring all the time, so we have to focus on wireless. There is also again it's classified into some three types. One is a inductive, capacitive and resonant. So these are all some of the methods we can able to do some wireless operation, that and all we going to see it. So these are main charging conditions is available for the EV. So all these things, as I said, we need have a charging infrastructure. Then we have to consider based on the requirement by the EV users, these are all charging portals we have to utilize by the government established on the corresponding location to make the EV with the charge on all the aspect. I am talking about faster and free manner can able to float it, because there is the chance if collapsing, that means that more number of EV vehicles are coming to picture, in the sense the charging station have some intelligence unit to accompany all the vehicles with the proper arrangements. That's and all have to be in the consideration. Come, we're going to see about some each and every categories one by one. First, I'm going to take a look of this conductive charging system. As I said, it's our regular charging mechanism. Like as a fuel station, it is kind of a plug-in based charging condition. If you take a look, the battery system, we have a DC. So based on the availability of the supply, we are deciding the condition. One is as a AC, another one is as a DC. Because sometimes, not sometimes, most of the time we are parking our vehicle in our home, in the sense we need to charge the vehicle. So that time we can't expect the DC supply from the grid. What is available with our case? It is a AC only. So obviously we have to opt the AC condition. AC based port, we have to use it for making the charging of our vehicle. As well as if you are in the travel or if you're in the moment of condition, that case you have to be somewhere, something like charging station. If you are going to enter there, instead of going with AC, the DC can be utilized over there. So due to this, what is the condition we are having? We have the charger, or we have our electric vehicle have to be support on both AC as well as DC. In that case only, our vehicle can charge anywhere, because like a petrol and diesel, here we are having a AC and DC. So, but in our real time, petrol engine can't able to work on the diesel fuel. Similarly, but here, whatever supply AC or DC, our vehicle have to be a capability to handle both the supply with more conversions have to be considered, and then have to be operate in the real world. So that and all we have to see it. So I hope you can able to view that different types of connectors which are all used for making the plug conditions. So that we going to in detail we're going to see it. So if you take this charging mode, that is conductive charging mode, normally it is classified into a three different levels. It will be there. What is the three level in the sense? As I already said, as a user, mostly we can able to charge our vehicle in home. Suppose if you are in the office or mall, some other case, in the sense public unit, there we can have with the public charging unit level, it will be there. Similarly, there is another chance. This and all having some restriction. The level 1 and level 2 depends upon the amp rating. I'm talking about the current which is flow inside. It will be very nominally, it will be there. Why? Because the residential and the public, that malls and all, we are not only generating the supply for EV vehicle. It is one of the appliances in a building or a residential. So that time, that maximum, if you are more number of current, it may be a chance of affecting all the appliances. So to avoid that, this level 1 and level 2 having very minimum rating of current which is used, and also the power rating can be less. Due to this condition, the charging also the time taken will be longer. But when you see into the DC charger, that is a fast charging mechanism is needed. That way we have to make very fast quick charging. Within a few seconds or few minutes we have to wind up the charging condition. So that, because many of the EV vehicle will not be in the lineup of making a charge, so that is very difficult. It should be as like our gasoline, have to be within a fuel, refill it within 2 to 3 minutes. It's a nominal time period to make the charging of vehicle. That time, that much of charging, so it is dedicated for this type of DC charges, dedicated for the charging station purpose itself. That's why that current rating is something like higher over there. Obviously, the time taken to charge our battery within a few minutes, which is 30 minutes maximum, it can able to charge it. Now the people are still working on this category to reduce even more. I think 7 minutes it came into picture now. So still the people are working by making the wider band gap of semiconductor devices to consider this much of charging, how to be more faster current flow can be achieved for reach the battery with more uh, full and for the traveling purpose. So like this, the levels are changed. So due to this level change, the ports also will get changed. And as I already said, as it is all we are consuming this charging infrastructure, we need to do all the aspect. In this infrastructure, we need to have one more main element is called as management system. That management system is nothing but it need a one centralized unit will monitor all the actions will done it in the charging station. That is, I'm talking about a grid kind of view as well as by the vehicle also. And based on this, the central management system will accompanying all the vehicle to the corresponding charging port, because when you are in the travel we can't tell that there is a charging unit with the DC support or AC support. That and all have to be maintained, and for that dedicated application have to be developed by engineers, and then it have to be installed it to the vehicle. So based on that, user can able to identify the corresponding place with, for example, if any fuel stations are available in the sense, that time if there is a vacancy slot is there, so the user can able to go and accommodate that place. Sometimes if it is not properly maintained, it is not possible because it is overlap, and then it is very difficult to charge the vehicle. Or suppose there is a chance the EV can only support with the AC, in the sense it is also have to look into it that manner, and then it have to be go on into it. Like that, we have this central management system. What this central management system will do in the sense, it will monitor the grid condition as well as the users conditions also. So based on the demand and based on the availability of the charging port, the central management system will decide and it will give the correct location to the user. Then only the user can able to go and take the charge, and then he or she can able to travel a longer distance. Here, in this case, we have different safety measurement how to look into it, because the plug-in electric vehicle, as I am talking about the EV vehicle, in this case, that our EV vehicle, if you take a look of the same vehicle is going for the charging station, there is the chance of faster charging have to be there. That time the flow current will be very higher on the case, and also there are some other protections we have to look into it for EV charging systems. So most of the requirement with all this electrical safety should be ensured in the charging station, which have to be protected in both charging station as well as EV. So overload, lightning surge protection, fault conditions. So those things and all, it's a regular EV supply that we'll get it on the power system problems. That same can able to affect on the EV charging condition itself. That should be monitored and have to be maintained. So this safety have to be followed in all aspect in the charging station as well as in our home. Residential also, if you are putting a charge, that should be also have this conditions have to be followed. So before going to this charging station, we need to follow some standards. So the standards should get maintained on both the conditions, either in the station side as well as also vehicle side. In the port, how far all these aspects have to be looked into it. For example, as I already said, the vehicle is one. We have two different supply. AC supply also is there, DC supply also is there. So whatever the charging portal we are using, that should have the standard of these conditions. It can able to handle both on board as well as off board, and also it can able to handle the DC charging, and also it have to be communicated with the embedded system. The CAN bus system communication have to be followed out. And another one more thing, electrical magnetic interference should get avoided in this kind of port. That should also have to be looked into it. So both the grid charging point as well as our vehicle charging point should have some standards. So these are all the listed out some international safety standards should get pointed out. So if you have seen all the port charging port that should have all these standards, then only it is safer to use plug point or portal for the EV charging as well as for the charging station. So for the similarly you can able to observe the some of the standards which is are used for the different conditions. In these international safety standards, the one of the key point is IEC standards only. First, you can able to see IEC 61851. It is one of the standard have to be followed throughout for all the charging ports. That general first itself we can able to see for AC system general requirement. You can able to observe for both DC as well as AC with general requirement. It's nothing but a protection. As we all I listed that overload, surge protection, all those things are there, right? That should be safer by this condition, so that ensured by this standard as IEC. Next comes electromagnetic compatibility. So interference will not disturb this, otherwise it will make the disturbance. I hope everyone know that EMI problem, electromagnetic interference, will cause the electronics devices with abnormal condition, it will makes the leads to failure case. So that's why that should be a protected one. Coming to the DC, you can see the same thing, but you can able to see the general requirement and EMC. Also you have to take a look of connectivity, because you that if you are connecting the charging point to the EV vehicle, that should get fitted very proper manner. There should not any leakage or any uh, loose contact should not be there. That should be ensured. And then you can able to see the digital communication. What is the digital communication I'm talking about? How far the charging and all happening, the battery level maintenance should get monitored properly, and have to be in the controller, have to be list monitor the battery healthy condition as well as in the vehicle consuming condition also. That and all have to be done by the digital communication. That standard also should get followed. And we have seen the ingressive protection. What is that ingressive protection? Is nothing but if our headphone, mobile phone, and all, we have that IP6 standard, right? So which are all some from the dust or water. If it is protected, that condition also have to be ensured. So that also have to be considered while making the charging port for the EV system. And here you can able to see more detail about each standard and its condition. As I already said, that first standard is only for the protection, which is 61851-1. It is used only for the protection. Next, 21 is mostly used for the electromagnetic interference and CAN bus system communications and all have to be happen. That is have to be followed. And 23 is especially for the DC protection purpose, and 24 is for digital communication. For both the end have to be ensured. So these standards are key features. It's required for all the charging port have to be followed while you are doing with the charging infrastructure, because there are different companies. If there is different of standards, if this follows, it's very difficult in the public charging condition. That's why the common standard policy regulatory should get followed for this case. Next, coming to the connector, this is the images you can able to see different connectors, plug points can be used for the EV system. You can able to observe here we have AC separate and DC separate. AC we have some rating of 2 to 43 kilowatt. You can able to see type 1, type 2 and GPT Tesla. GPT is another one of the universal based of chargers. You can able to consume both DC and AC, but you can able to observe the differences in the both the port. And also if you can easily observe the connectors pin conditions also, it will not be same as the DC. The structure of the ports mostly it is a different. You can able to observe it in the case. Tesla is the uniformity. It can able to support both AC and DC. That's why it is in this setup question. So uh, here CCS1 and CCS2. It's a universal charger port. Why I am talking about universal in the sense, you can able to observe there is two element in this port. One is for the AC, another one is for the DC. So with the same port, you can able to see the just a second. Okay. So in this case, you can able to see, we can able to observe both AC one port and DC two dots are there, right? So that we can able to utilize. Like that, we have different based. So DC side, you can able to see only two main holes to make use of the connecting positive and negative. But coming to the AC, we have a three phase and single phase. Based on that, the ports configuration has been varied over here. So more detail, you can able to observe our India, we have used this kind of charger ports, Bharat AC 001, which is mostly used in the home appliances. Home, the rating itself very low. In our homes, we can use this type of supply. Coming to the bar DC, that and all is mostly on the public sector. And CHADEMO, Chemidio charger, this will be mostly used in the public unit, which is only support only a DC supply. As I already said, CCS, you can able to observe this. This is only can support both AC as well as DC. So now we're going to see that CCS2 is also type 2 condition. You can able to observe here there is a two ports are available, right? With all the dots, it is all configured. Based on this, what are all the elements which are all there that we can able to see over here. In the bottom, if you take a look, we have DC plus and DC minus. We have female element as well as male element, male connector and female connector will be there. Based on this only, you can able to integrate within the charging station with the electric vehicle. So the lower oval shape you can able to see that is only supported for DC. Because why this type of charges is needed in the sense, we don't know the vehicle condition, either it will support for the AC as well as DC. That time it will be supported on both the conditions. That is why it is used for this case. Now for DC, it is very easy. Only positive and negative only is going to be there. So from the female pointer, it is DC positive in the sense the male pointer DC negative will get connected. Similarly, that vice versa, it is going to be connected. So here you can able to see in the AC system L1, L2, L3, which consisting, but it is a three-phase system. That if you are going with three-phase, this line 1, line 2, line 3 is going to be play a major role. Along with neutral, that means star connected, you can able to achieve in this case. Along with this, we have PP is there, proximity pilot, which is when you are inserting whether that it is properly connection happen between a vehicle as well as charging station. That should get ensured out. After this ensure, the control pilot can be make use for the flow initiate the charging condition. So CP and PP should get first connected, and then the signal have to be properly communicate between a vehicle and charging station. Then only the proper charging can be done. So this have to be ensured. In between the green color, you can able to see it is a protective earth purpose. So I hope the fault overload, underload, and surge condition that earth connection should get properly there. So is provided in this case. So this is the port of type 2. Similarly, if you take a look of Chemidio, it's a as it is Japanese model, you can able to see there is only a DC port you can able to connect from this. So the orange color, what you are observing, this is supply, and we have other than that we have different ports pins are there, which are all used for making the proper proximity connection, ground connection, then charge sequence. How far when you have to be charged, when you have to be stopped, all those things will get there. And along with that, you can able to see there is the CAN bus is there, which is nothing but how that battery is getting charged very faster or slower. I hope everyone know if you put a fast charger in our mobile phone itself, at when it reach up to 80%, it will be very fastly charge the battery. When it reach 80%, it's try to start with a slow manner. So those type of all this communication have to be properly maintained by use of the CAN bus. So for that, link have to be there in between the port of EV as well as charging station. Okay, as I said, due to this much of port, the CCS is plays the major role. As I said, it have both AC as well as DC charge in a single port. So which makes you can able to support for both the conditions. So that's why it is lead compared to other charging ports. So people also need this type only because then only they can use it to charge anywhere without any conversion conditions and all. Okay, now coming to the real point of view, this is the really available on the market. We have some AC mini plus EV charger, which is only applicable for the household. So from the house, you can put this one and you can charge the vehicle. So that condition, it will be utilized for the AC mini pulse. Next is AC charger with. This is nothing but you can able to observe this next level, that is expanded of the previous residential condition. This will be going to use. It is follows all the standard, as well as if you take a look of this and this also, both the common things you can able to observe the connectivity. So this type of charging port should definitely have a Ethernet connection to for making the monitoring as well as management of these sources. And also user authentication is nothing but how far that you are going to charge for each charge. I'm talking about how far you're going to pay the charging, that also will going to be considered over here. It is next level of first condition. Next is DC charging. If you take a look of charge port with the DC, it's all for the public sector. So this is type having single port condition where you can charge with the maximum of 40 to 85 volt with all other aspect, Ethernet and other things, but this will be applicable only at the public unit. There is another charging unit, it's called DC wall box, which have high power rating. Here, what is the thing in the sense, it have two different port, you can able to observe it, and simultaneously with a single charge point, you can able to charge two vehicle. So that is we are having in this option. So previous three products have only charged one vehicle at a time, but this product can able to charge one more vehicle for the operation. Same as you have another one more charge with very fast condition. It is 50 to 150 kilowatt of capacity. This product is in the market to make use of charging the vehicle. So in this case, you can able to charge three vehicle at a time, but that three vehicle, if two vehicles are DC in the sense it can able to support, and one AC it can able to support. So from this, it also can support three vehicles simultaneously by making the charge. So like our regular fuel station, that you can able to take petrol, diesel, super petrol and all, like a speed petrol and all, like that we have three different supplies. You will be, sorry, three supplies can able to take it out, but one is DC, sorry, two is DC, one is AC supply, you can take it from this case. So these are all ready-made market availability products which are all there for making the charge the vehicle. Okay, so far we have seen only about the standard. I just make the summary of the charging station. We have seen the standards. We have seen some different ports and how their pins are configured in the condition, and how in cases of real time, how all these ports are manufactured, and how the EVs are considered for making this type of charging. These products will be consumed based on the availability of condition. As it is a residential, we have to focus on the first level, and then if it is a public or office unit in the sense, we have to focus on based on the vehicle and the charging mode on that place that have to be decided. Next technique, it's a battery swapping system. So far, the conductive charging is over. Now we are moving into the battery swapping. It is a kind of an interesting factor. Why? Because this is nothing but for this battery swapping, there is lot more constraint have to be followed over here. What are those constraints in the sense? As it is simply, I am talking about the battery swapping in the sense anybody can able to come, they can replace their battery, and then they can get the new battery, and then they can go further. In this case, the charging time is getting eliminated, and for this type of, you can able to observe the scooty kind of thing. It's a handy battery, so it is very simple. The people can simply take it and then can replace with the new battery. But the thing is, all the vehicle should follow the first constraint is universal battery have to be considered over here, because we have different companies will be follow over to this, but all the companies have to follow the same type of batteries. type of battery I'm talking about, same structure of battery have to be followed, and as well as if it is lithium ion or something like lead acid or different types are there, mostly of lithium ion in the sense that should be properly packing in the same category. Then only this will be applicable. So in this battery swapping is another biggest area, and also more research have to be focused on this case. So we will see one by one. If you take a look of battery swapping, as I said, it may be a small vehicle or big vehicle, easily to can change the battery by replacing with other battery. Here we have to use excess battery for making the replacement, and it will take very few minutes to make rechanging. Okay, so as I said, the common battery have to be followed, because everyone have to use the vehicle in the sense the common battery have to be replaced in very proper manner. So that is the main thing about battery swapping station purpose. So you can able to observe this type of station will be there as you are a regular user of the battery vehicle, they can able to log in and they can get the battery out. If suppose unauthorized person, if they are coming and replacing the battery, that will not be possible, because only authenticated user can able to open the lock and take the battery. Others can't able to do it. So separate vehicle manufacturing, they have to establish this type of swapping station to make the replacement of the batteries. Actually, this also is not a new thing. Already in the olden days, in 1896 itself, the battery swapping already the concept has been done, and it is implemented, and it have been done it in the practical case itself to avoid the charging time period to longer. It's not prolonged, so you can able to replace the battery and you can go on further. So in this case, what are all the restriction we are having that we have to be seen in this case? As I said, if it is a universal battery that we are using in the sense, there is the chance of battery getting damaged or something like degraded may be occur. For example, one user are using the battery for a longer time, it is getting degraded level. It is damaged and its charging also it's poor. He or she come and replace with a new battery in the sense, it is going to be cause a difficulties, because that old battery is affected and lifespan is very poor in the sense that should be get monitored and have to be properly have to be replaced for other users. Suppose if the not proper management is not there in that case, there is the chance if the battery is again recharged, if another user is taken in the sense, again the charging and lifespan is very reduced over there. So this and all is the inconvenient places it is there. So this have to be looked into this swapping stations. So these are all the research area how to be looked into it. Coming how the evolution has been done in the sense, first one by one we had some separate place where you can able to swapping. That swapping has been done. If it is a, as I said, two-wheeler, it is very easy. But even though the weight also is a matter, all can't able to replace the battery. Only with the stamina people can able to lift the battery. So that lightweight batteries have to be maintained with the swapping technology. That in that sense, the battery manufacturing unit have a huge demand on this case. If you take a look, there is a chance of portable battery swapping can be done. That conditions like how we are having portable vehicle service systems, like that we have the portable battery swapping also will be there. This will be most applicable for the heavy vehicles like buses. Why? Because the buses with a huge number of public have to be transmit. That time, if the bus is getting charged in the sense, it is very much difficult. So to avoid that, this battery swapping it will be more applicable. So China already introduced these things, as well as Korea also introduced for the using this bus with swapping technology. Okay, in this case, there are four different types of swapping technologies we can able to see over here. How that battery swapping can be achieved in the sense, if you take an electric vehicle, we have a rack for storing the battery. That battery should be in the uh, left side, right side, bottom, top. So like that, side manner it is also there, and also bottom and top also have to be considered for the battery swapping. Depends upon the condition, it will be decided out. Okay, mostly sideways swapping. if you take a look of sideways swapping, it is more convenient by all the vehicle because it is more suitable. As you see, the van type of vehicles, it will be more convenient for this sideways swapping. Next is rear swapping. Rear swapping is nothing but we need a large boot space for making the swapping of battery. So on that sense, the battery should be at the back side. So that have to be properly maintained and placed should be there. Next is swapping method is a bottom swapping. In this case, we need some hydraulic method used for this to lift the vehicle, and then we have to replace the bottom battery and then replace with new battery system. So here we need some new uplifting technologies to replacing the battery. Previous two things it is not required because side and rear it is easy to make. Not easy, I'm talking about there is no extra mechanism over to that, but this bottom swapping it's need a extra mechanism to lift the vehicle and then change the battery system. Next is top swapping. Top swapping is mostly done with the heavy duty vehicles like bus, lorries like that, because in this case the batteries are placed at the top position so they can able to replace it proper manner. To lifting the buses with hydraulic, it's also a very difficult mechanism you have to follow over to that. To avoid that, this type of top swapping can be achieved in this case. Okay, so as we know, different type of swapping mechanisms will be there, but how we can going to be consider these cases, because each, if after swapping that batteries have to be what we have to do the charging, so that refilling have to be focused over here. How to make these conditions that we going to see it. So to establish the battery swapping station, we had some technical hurdles over to that. So one is, after collecting the battery, we need to charge the battery, and first itself the battery life have to be checked by the health monitoring should be there, and then scheduling, because without scheduling it is not possible of making this swapping. This scheduling will applicable for all the charging systems. Conductive is required as scheduling. This also swapping also required as scheduling, and also next wireless also is needed scheduling also. And we need a technique how the battery with effective swapping we're going to use it, that also will be how to be looked at. And then for charging that battery station, that means after swapping battery, that battery have to be charged, right? That should be not only supported from the grid side only, also with renewable support have to be there, and also location. This is applicable. One of the common terms should be there on both conductive as well as battery charging. One is charge location to identify. There also we required. Here also it is required. And scheduling. Here also it's needed. When the swapping can be done, that also scheduled first, and then only it can be done it in the proper way. Okay, as here also aggregator is needed. What is the thing? How, like the same as central management system, here it is also is needed to monitor all the conditions, because the EV have to be swapping have to be done, where it is have to be done. Those things should be commonly. That means communication should get properly maintained, and then from that it can able to charge it. Some because the user will not get the failure battery, or without charged uncharged battery the user will not get it on that case. So that should be ensured with these conditions. So for that, how the architecture have to be done it for the battery swapping, in the sense you can able to see after collecting the battery, that is discharged battery, then how to be placed, some system have to be follow over here, where you can place all the battery in the sequential order, and then you can charge it at simultaneously. Here the charging mechanism have to be get it from the grid as well as renewable. So then only it have to be done. After charge, that should be monitored and have to be replaced, and then have to given to the user. That should also have to be followed over here. So like this architecture have to be. This is after getting the discharged battery. We have to use for the charging condition. In this, we have different modes are there. First mode is a single battery swapping mode. What is that single battery? In the sense, the vehicle is entering into the station. it will take the battery, and then it is giving for the empty battery is given to the station, and then refilled battery is will fitted to the vehicle. So then the vehicle can move out. So this is called as single BSS condition. In this case, only the battery swapping alone can be done, and it can be charged on that place. Meanwhile, whatever charged battery that can be replaced over here. But with this case, we have some constraints will be there. Only swapping can be done it on this case. We have another mode is there, which is a multiple BSS. It is nothing but we have different combinations we can able to have over here, which is you have the chance of multiple of battery units you have to be followed. The central management system should monitor all the cases, how the swapping, which are all the vehicle need a swapping of battery, those things should get monitored properly, and then which station is near to the EV that have to be floated over there, and also the user have to monitor that whether that station having enough battery over there or not. Suppose after entering in that, if there is no battery stockage, that also will cause the delay of charging, and also it is very difficult for the cases over here. So you can able to see all the different combinations. That's why it is a multiple BSS concept. Here you can able to charge the system. Here also the swapping is done, only swapping, but multiple tasks is done it at the parallel time. Next is BCSS along with battery charging. Here it is nothing but hybrid of conductive charging as well as battery swapping. It is nothing but in a same charging unit will have both the facilities. It is called as BSS and BCS integration charging unit. Here the user can get the condition. Suppose EV user want to replace the battery, that option can be done it over there. Suppose no need of making the swapping, instead of that there is a time for making the charge my vehicle, in the sense that time they can use the battery charging station, they can use it. So that time the slot can be allocated, that is like our regular charging condition, because whether there is a place is available for put our vehicle for charging, that and all have to be considered. That type of control unit have to be followed for this case. So you can able to see as a user, if he or she has accept that swapping, they can go with the swap portal. Otherwise, they can go with the charging conditions. Next comes here, it is the battery. How far the charging strategies we going to follow for here to swapping. After swapping, we are doing the charging, right? That charging have to be considered on all the cases. Suppose consider there is battery swapping station is there, but on that time due to there is very small amount of vehicle only is there, but there is in the station many of the batteries are fully charged, in the sense that act as a backup for the grid condition. So that type also it will be there. So the charging strategies should get followed over to that, when it have to be charged and when that batteries have to be discharged, that also have to be considered in this case. So based on this, as I already said, when the swapping station receive all the battery, the first foremost thing it have to be look the health of the battery. So that also can cause the problem to the battery condition. If damaged battery, if it is charged also, it will affect the other batteries may chance. So that should be get monitored properly and should get replaced at regular monitoring should get maintained over to that. So in this case, uh, that energy management by the battery should get properly conditioned, because when the rack of battery that you are going to make a charge in the battery swapping station, that will be very faster it going to be charged. So that time the battery should have the handle of high temperature, all those things. So they have to make the thermal management for the battery charging should get maintained over to that. This is applicable for vehicle side also. Sometimes when you are dealing with a fast charging mechanism, that time the battery should have coolant condition with proper manner. Then only the charging can be achieved without any flaw. So that is you have to be follow for this case. Here you can able to see the battery station, or as I already said, it is purely depend on the grid condition. Suppose if the vehicle, that means battery is there so much in the station itself, in the sense they itself act as a one energy source to the grid. So this, in this case, you have the grid stability can be maintained, and also you can achieve the load demand by the system. So that is can be done it with here also. So like how with the renewable energy sources, this battery swapping station also will act as an energy source for the grid. That depends on the condition category, not for all the conditions. As I already said, battery should get protected and should get monitored properly for all the vehicle, which makes damage and degradation can be avoided, and also degrade battery charging can be also avoided in this case. Here, to establish this type of battery swapping station, all the manufacturers should follow a uniformity. So they have to follow the common battery rack in the system, as well as that port also have to be considered. So universal pack slot have to be used over here. Battery should be remains the same for all the vehicle, and also the placement of the battery also should get maintained same. Universal battery pack slot have to be followed. That is a UBP should get followed by the EV owners, that we can able to use it for that case. Then only this battery swapping network can easily do all its work. So we have a battery sharing station in the sense that we need a communication protocol which is IoT enabled have to be there. Then only we can do all the swapping without any delay functions that have to be followed in this case. So the battery sharing network with we have for all this condition monitoring. So as I already said, this type of network, it is common for both previous charging condition as well as for battery sharing charging also. It will be applicable. So it need to be properly maintained. This network have to be check all the EV charging station, swapping station, and the grid condition. Everything have to be maintainedly have to be followed over here. So special network we have to be followed over here. So what are the challenges here? So while in the discussion itself, while in the session itself, I have listed all the conditions. So these are all the challenges we are having, which are all interchangeability, feasibility infrastructure, and battery degradation and ownership. Who will take the responsible for making the swapping of batteries? That also have to be the biggest challenges, where people can do a lot more researches to give the solution for this kind of problems. So interchangeability, you can have seen this, the all the battery should get properly have to be single manufacturer condition have to be there, and simple it have to be replaced. So that only interchangeability. Suppose as well as feasibility. So changing the swapping itself, it is a sometimes like bottom swapping system, it's a difficult, right? So that should be commonly follow with some rear or side. So like that it have to be followed in the sense most of the charging can be done in very feasible manner. And also this type of station need a large more space for an infrastructure. So have to be established and have to be compare all the batteries with proper manner. And battery degradation. As I said, as a user, there may be a chance the vehicle may be a older one, the battery also degraded. So that time, if it is replaced in the sense, that should be keenly noted and have to be user will get the notification of the condition of the battery, and based on that, the charges have to be very for that user. That and all have to be there. And another thing, battery ownership. The manufacturer have to be follow the uniform placement of the battery. Then only it will be fruitful of implementation of battery swapping can be achieved in this case. So until this, we have seen about all the battery swapping methods as well as challenges and the research areas that we can able to look into it. Next charging method is wireless charging. So in this case, we have to use some wireless charging condition. That means we need a transmitter and a receiver port to the vehicle. The receiver should be placed on the vehicle itself to get the charge. As well as recent of upcoming years, definitely in a vehicle itself having both the receiver and the transmitter. What is the purpose in the sense? There is the chance of charging the vehicle between two vehicles can charge mutually charged by itself. So that type of technologies may be arrived for this case. If you take a look of this case, we need a high frequency converter to make these signals. That means charging, we have to use it for the coil only, we're going to make it. So wireless charging can be done with the help of high frequency converters have to be focused over here. In this type of systems, the current, how far it is sharing, that should be get monitored properly, and it will not affect any of the living beings. That should be ensured about. So if you take a look of wireless charging systems, there is three types only we have seen. There is another one more type, it is a magnetic, that we're going to see it over here. The three types, it's an inductive type, capacitive type, and resonant inductive we have seen. Along with that, we have gear based, magnetic gear based power transfer also we're going to see. So like that, we have different types of charging, wireless charging we can have over here. First, if you take a look of inductive charging station, you can able to see this is the schematic diagram. As you are having the supply which is connected with the AC to DC converter with inductive coil have to be there. For this inductive coil, we need separate transmitter pad, which is nothing but it should be placed at the parking system where you can see it in the real time. If the vehicle in the correct position of that plate, that means the transmitter plate should get properly placed it on the receiver side. That should get correctly placed. Then only the charging can, inductive based condition can be achieved. Due to this, the battery can be charged to the vehicle. So this type of charging, we call it as the inductive power transfer for the vehicle. So in this type, we need a separate pad in all the parking areas. Then only the charging can be feasibility done. Next is capacitive wireless charging. Capacitive in the sense, one of the plate have to be in the transmitter side, another plate is connected to the receiver side. So in this case, you can able to see the rectifier unit which is connected in the parallel plates only. So this also, in this case, there is no need of pad is not required. Instead of that, the another plate where we are placing, that is the another biggest thing have to be considered over here. Next is magnetic gear wireless power transfer. It is nothing but you can able to see there is two permanent magnet motor have to be there. It's a kind of a generator action we have to follow it over here. The transmitter will have 1 pm. The receiver also will have 1 pm. Both are in the rotational operation. First, both the transmitter and receiver should get properly air gapped. So the air gap should get very minimal. Then only the transmitter rotor, if it is start rotating, it will get coupled. That means magnetically coupled in the receiver side PM rotor. That time, if the transmitter side start rotated, same as the receiver side rotor also is start rotated. Based on this, it is internal generator will produce the supply for the battery. In this case, there is the chance internally it can able to the transmitter act as a prime mover. It is coupled in the magnetically. It is coupled with the receiver side, so it can also rotate. It can able to generate its own supply and it can store it over there. So this is the way you can able to charge it. It's a new type. It is there. It is the fourth type of the wireless power transfer method. And another thing is the resonant inductive power transfer. It's the same as inductive power, but it is an advanced one is there. It is resonant, we are have to use it. What is it? Resonance in the sense we are correcting that power correction, and then with capacitor placement, capacitor filter have to be used for the compensation purpose. With that, we are going to do the transmission of the inductive conditions. So this is another type. Okay, in this case, so far we have seen all these types of wireless powers are static type. Static type in the sense only vehicle is in the hold off condition. Off condition in the sense only vehicle have to be without any movement. It should be stand stable. Then only this type of charging can be achieved. Wireless powers can be achieved. This type is called as static type. We have another type also is there. It is a dynamic type. Dynamic type, it is in the developing stage because when the vehicle in the momentum condition itself, the vehicle can keep on charging itself. So in that sense, you can avoid the charging condition. So both battery swapping and conductive charging is not needed over here. Instead of that, if the vehicle is getting low charging condition, automatically it can charge it. But this type of dynamic type is needed in the sense it need a lot more infrastructure have to be placed in the roadside itself. So this something like it's a very costliest to one, and if this is in the case, it can able to simply it can able to travel like our electric traction. So how far that supply can able to track we needed that time it can able to connect it to the supply. Similarly, it should be place it on the roadways to make charge in the condition. But we need a special road for this type of charging mechanism. So there is another unique case it is there. To make this dynamic type or stable static type, there is another type is there. So far we have seen all the receiving plates are connected in the vehicle only. But this is something like interesting factor which is in the wheel itself they are placing the receiver coil. So in the road, the transmitter coils are all placed. At the momentum itself, through the wheel, we don't need extra accessory to make the charge. With the help of the wheel itself, the charging can be done. It's a kind of an interesting factor because we need extra elements and all for that. Instead of that, by movement itself, the rolling itself, it will get charged up. But as it look like an interesting factor, it is very much difficult factor also. It have to be charged with very sequential manner. That should be very difficult in this case. Oh, from this, next is about the challenges. As we discussed this, how far the charging power is getting increased, that much of complexity also is getting increased. So, as it is the static type, it is itself very difficult. Now, that's why all these semiconductor devices are play a major role to make use of this, and the coil have to be transmit the supply properly without losses. Those things and all coming to picture. Similarly, for the conductive charging also, will have all these things. So as per as the charge power is getting increased, both wireless and wired, it is the complexity is getting higher for that case. So these are all the elements where the people have to look into it and have to give the solution for that to reach the fast charging with smart way of charging with reduced time limit. Okay, so we reach the conclusion part. So I just make the brief summary over to this. First, we have seen how the conductive charging we have adopted nowadays in our real-time world, and how it is getting scalability have to be done with all the standard aspect you have to be considered for the case. And next thing is the wireless charging. As we discussed that wireless charging, it is looks like interesting, but the safety matters is there because due to the charging time, if any living beings over to that, it won't affect that, and then it have to be charged the vehicle. So that and all have to be looked into it, and then have to be decided on. And swapping, the swapping as we are seeing this, and if it is a swapping happens in the sense that swapped battery should get faster of recharge have to be there, and that infrastructure have to be established should be focused over there. So in future, all these things club together, the people will make a development with more effective of charging without any delay and easy way to make the swapping or whatever the user requirement. Uniformity have to be followed for the charging port. All will happen on this future. So as per the research concept, it's a quick summary. You can able to see all these charging portals where the semiconductor devices have to be looked into it. All will be in all the aspects have to be focused over here. Whenever the ultra fast charging and all is needed, that we need a proper cooling mechanism have to be followed, and a better load management, everything have to be followed. So that type of technique for the conductive charging have to be looked into it. Coming to the wireless, as I already mentioned, in the moment motion charging, don't know how it is going to be worked it out because it is very difficult in proper charging on that sense. So effective charging also without lossless, the motion charging it is the biggest task. So these are all effective have to be there. And as I said, the health should not affected by the human for wireless charging conditions. Another is battery swapping. This should be a faster and errorless. Error I am talking Decayed battery should not be replaced for the user. That and all monitoring and uh, management system have to be incorporated. So those things have to be followed for the battery swapping. Coming to other side, we need a incorporate of perfect industry oriented IoTs and AO enhancement should be there, which makes proper scheduling and proper guidance of the location. All those things can be done it with this. And also, if you take a look, this charging station will look into a green battery development, which makes with faster battery for that type of technologies have to be incorporated for the battery manufacturing side also. And to reduce this environmental friendly have to be considered for the battery unit. And finally, all these things should get regulated by the government policies and regulations should get followed for this to achieve this type of energy swapping station. Okay, so these are all the research areas. Finally, my question is, where is EVs are green? Is it so? Actually, if you take a look, EV is not a green energy. Actually, still we are affecting all the environment. I hope everyone's seen these memes everywhere. That is the true only. We have to replace the battery as a green battery, and the charging places also should get renewable or integrated. Then only it will become a green energy for the EV system. Okay, so that's all about in my side. Thank you all of your patient listen. If you have any queries, you can let me know. We'll make the discussion.
Thank you very much, sir. Participant, if you have any queries, you may post the same in the chat box.
Okay.
Sir,
In
there is a
the
query.
chat box,
Yes,
yes,
sir.
sir.
The chat box, the queries have been placed also, sir. Please comment
Actually,
on efficiency of wireless with respect to wired technology. Someone has asked.
still it is yes. The efficiency point of view compared to wireless, wireless is poor only because still lot more of research have to be focused on all the cases, inductive, capacitive, and all different type of techniques are there following out. But the people still working on the charging unit over there. Then only the lossless charging can be done. But from this point of view, until now, the wired charges are more effective than the wireless. So still, a lot more research have to be focused on that case.
Someone has asked a question, sir. Various methods to improve the efficiency in wireless charging. I think the same thing that they
Yeah,
have
it's applicable for here also. It's
here
same
also.
thing.
Yes, sir. Yes, sir. Sir, how to improve the DC fast charging using multi-level inverter topology? Someone has asked like that.
Okay.
I think
Okay,
it's
still, actually, if you take a look of multi-level inverter topology, still it is in the level-wise itself, it's very low case. But if you take a look, the industry also now only they are acquiring that multi-level with very limited versions only. So still there are a lot more focus have to be there in the multi-level inverter concepts. In the DC to DC itself, the people are looking to more faster charging conditions. So that's, I think that is the answer fit for this case.
yes, sir. Bidirectional converter will do this work.
Yes, do all the aspects. Because if you go with multi-level, you are causing more switching problems into the system. As much as switching will get higher, that much of electromagnetic interference also will get affected, and efficiency will get questioning over there. So multi-level, compared to multi-level, other DC to DC fast charging is more effective for that case.
Thank you, sir. Thank you very much for attending all the questions, and thank you very much for accepting your invitation for this ATAL FTP, sir. We honor your presence over here, and we are very much precious to have you from Amrita Institute to deliver the speech on the electric vehicles, sir. Thank you very much for your kind speech, sir.
Thank you. It's my pleasure, and I hope everyone will get some fruitful information from these energy electric vehicles charging stations. And I hope most of you can have some idea on this research oriented, because most of you want to do the charging stations are all it's developing and evolving areas. So people get some hint on there. You can start that your research for your career application and all other things. Thank you. It's my pleasure.
Thank you, sir. Thank you, sir. Now, participant, we formally close the session as of now, and the feedback link has been posted in the chat box. You may fill the same, and our next session will start by sharp 7:30. So you may stay here. The participant may fill the feedback form as early as possible.